Good afternoon and welcome to Design Master Training. My name is David Robison. Today we are going to be answering some questions about Design Master Electrical for AutoCAD. If you're attending the training live, you can ask questions in the chat box. If you're watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497 and our email address is support@designmaster.biz. We are going to be answering some questions that we've gotten through our regular support channels, questions that I thought would be interesting enough for everyone else to see answers to. The first question is someone asking, they've inserted all of their rooms on their lighting drawing, and now they want to know how to insert them on their power drawing. And so I'll go ahead and show you how to do that. The first thing you need to do is actually insert your rooms in your project. If you're not familiar with that, we've got the building section where you can define your rooms. Rooms are not used for a whole lot in the software. We can do some basic lighting calculations based upon the rooms, and we can also use those room names to fill in circuit descriptions. Other than that, the rooms are not used a whole lot in the electrical software, but we do have them for those purposes. So we can run the insert or create room command. And I'm actually going to zoom in so I know what I'm creating here. We'll call that room 101. It's going to be a kitchen. Create this room. And so we have to actually specify the boundary for this room. And then we'll do this concession room as well. So now we have two rooms defined. And we could continue going through it like that through the rest of the project if we wanted to. But this is all obviously all on our lighting drawing. Now we want to show this on our power drawing or our power plan. So I'm going to go ahead and open up the first floor power. So we were on first floor lighting. We can open up first floor power. And to get those rooms to show up, we have a command for that. It is the insert room outlines on this drawing command. Run that command. You select the floor to insert. So when you create a room, there actually was an option for which floor it went on. So it'll insert all the rooms from that floor. Click OK, and it will insert those rooms for us. So now we have the rooms on the power drawing, and we have the rooms on the lighting drawing. So you only have to draw them once, and then they'll be recreated in the other drawing for you. That works if you have separate drawings. Well, if you have multiple floor plans on one drawing, a lot of times you'll do your lighting and power on the same drawing. You'll just have two copies of the floor plan like I've done here. So say we've got our power down here, and then we actually want to do our lighting up here. What you need to do is actually define a second alignment point. So if you're not familiar with those, they look like this. It's kind of the origin for our software of all the coordinate systems. So we have one alignment point for this floor plan down here. We need a second one up here. So we'll insert an alignment point. You want it in the same location as the alignment point in the other drawing. It happens to be the insertion point of this XREF. For whatever reason, the architect put it the 00 of this building here, which is an odd spot, but we'll just match it. So we put the alignment point in there, rotate it, and then we draw a box around our floor plan. And so now everything in this area is going to use this alignment point. And then we run the same command we ran before, insert room outlines on this drawing. It also can, so it's going to insert it on this drawing, can do it in a separate area. So we'll select that first floor again. And then it's going to prompt us. Now we have two areas. It'll say, which area do you want to put these rooms in? We'll select this area up here. And so now it puts a second copy of the rooms up here. So we have the rooms in this area and the rooms down here. So if we add light fixtures up here, they're going to know that they're in these rooms. So that's how you do it if you're using a single drawing for your floor plans. We work either way, depending on what kind of workflow you like. Next question is also related to rooms. And that question is, how do I get the room names to show up in circuit descriptions? As I said, that's one of the benefits of room names. If you lay all these rooms out, you can see that these receptacles on your panel schedule, that they're in room 101, and these ones are in room 102. So you can actually have that labeled on the panel schedule. So these are on panel A, and we will update that A panel. And you can see that we've got all the load types being listed, but no rooms being listed. And so to get those displayed, there's actually an option for that. So if we go to the customization, and we go to options, and then in the circuit section, so there's the include room names in circuit descriptions. Change that from no to yes. There's two yes options. We can include room in the description or not. I will include the room just so you can see what that looks like. Click OK. And then we update this panel schedule, and it will fill in those circuit descriptions, including the room names this time. So now you can see that we've got those receptacles in those rooms, and also those light fixtures are in those rooms. And you can see that if you got multiple rooms, it kind of lists all of them sequentially in that circuit description. That is displayed on the panel schedule. If you go to the circuiting command, you will notice that the rooms are not listed there. That's just kind of a legacy historical way of how we're displaying this data versus what's on the drawing. So if you pull it up in the circuiting, your rooms aren't going to be listed. So if you need to see it for your own purposes as you're doing your design, you have to update the schedule and look at the values there. Pulling it up in the circuiting dialog won't tell you. But if you update the schedule, you can see the room numbers there. So that's it for our room questions. Then we had another question related to modeling a distribution system in a one-line diagram. The question was, how can I double tap from the primary side of a transformer to feed another transformer? So looking at this arrangement here, the customer had some sort of main panel or possibly a utility connecting to a transformer in the project, and the transformer then connected to stuff downstream. He had a second transformer, and he wanted to connect to the taps on the first transformer and just do a connection between these two. With panels, we have the option for double lugs, and then you can do a double tap very easily. Transformers don't have that option, so you have to be a little more creative, but it can be done. So just to show you, for a panel, you would just change the lugs from standard to double. And if you have double, I'll take that A panel there. When you do your panel connections, if you're connecting to panel A, you have top lugs as an option for the connection. So it's very easy with the panel to do a top lug connection. It's just built into the software. For a transformer, we don't have that option. If we go take a look at transformer T1, there's no lugs setting, so we can't make that happen. Instead, the best way to handle it is you need to put another piece of equipment above this transformer and do your connections to that. So you're kind of faking it. You just really need to get the model looking right, and so this is how you're going to have to do that. So what we'll do is we'll use the enclosed breaker, which is kind of my go-to for a lot of these special modeling situations in your system. And we'll make this breaker, and we'll call this T1 lugs. So now we have a breaker. Pretty sure that's going to be 480 volt. And it needs to have 2 taps, so we can make 2 connections to it. So we set the taps to 2, so we've got the T1 lugs breaker. And so now for our connections, we take T1, which is currently connected to MDP, and we're going to connect it to T1 lugs instead on position 1. And T1 lugs will then connect to MDP. So I will manually insert that so that it lays out nicely. And we will do it as a custom box, and I'm just going to draw a little box for that piece. So then we've got the connection to that disconnect, and then the disconnect to the transformer. And then for the connection to T2, you connect T2 also to the lugs. And we update the one-line diagram, and it draws the connection. So that's how it's all connected. This is basically modeling the lugs. You wouldn't probably want to draw it like this, so then there's a couple more steps you might want to go through to clean this up. Rather than actually displaying this, you probably don't even want to display this piece on the one line. You probably want to remove it from the one line and just do your connections without it. So you can go to the lugs definition, and we can turn that off on the one-line diagram. You probably also don't even want to see it in the voltage drop or other places, so you can choose how you want to have this show up in the various pieces. So we can turn it off in the schedules, because this is kind of, we're just using this to get the connections right. but you can show it, turn it off so it's not going to be showing up, or leave it on. And then if I erase all this and update, T1 and T2 are basically connected to this, and then you can redraw this feeder to have it connecting to T1 there. So I will redraw that feeder. And we could take the breaker off and again, continue to clean that up. But that's how you model that with our software. So now the loads are going to transfer properly, so all your calculations work right. So it's a bit of a workaround to make that happen, but you can do double lugs through a transformer. So I've got a couple questions in the chat that I can answer. The first is related to alignment points. I'll pull up this drawing, which has two of them. And the question is, what's the meaning of this orientation, of this rotation? That is the north direction on the project. It's not so important other than it just needs to be the same for all areas that you put it in. For these interior areas, obviously, it doesn't really matter because as long as it's the same, you put it up, you put it to the right, it all works out. Where it more comes into play is if you then are going to model the exterior of your building, do a site plan, and you want to get some distance calculations working properly there. On the site plan, the building's often rotated differently than it is for your floor plans. So you set this rotation differently on the site plan so that it's pointing in relatively the same direction. So you just want it pointing in the same relative direction on all your plans, and then everything works out properly. So mostly it's for on the site plan, if the building is rotated differently than the floor plans, rotate the alignment point to match. Then there's a question, is there a way to rotate light fixtures all at the same time? The answer to that is actually no. So say you've got all these light fixtures and you want to rotate them all 90 degrees. There's no way to do that. We kind of depend on the generic AutoCAD functionality. So, I mean, just the rotate. So there's nothing in Design Master for rotating anything at all, actually. So you just use the standard AutoCAD rotate. So having said that, you actually could select them and then use just the AutoCAD properties to rotate them 90. So you can do something like that. Oh, there. We had to run a command, and there we go. It updated. As soon as when you update the properties dialog, we don't get alerted that something's changed. But as soon as you run a command, it sees that something has changed, and then it reconnects all the loops for you. So if you need to rotate multiple things, that's more of an AutoCAD drafting question. You just handle that in whatever way you would like to handle it in AutoCAD. There's another question. How to add power to junction boxes. Junction boxes are a little tricky because there's actually 3 different ways you can do them in the software. If you insert just a standard junction box using our insert junction box, you actually can't power it at all because there's nothing there. It's just a box. So if you insert a junction box, and if you try to circuit it, nothing is going to happen. Because it's just a junction box, there's actually nothing to circuit there. Instead, you need to connect that junction box to devices, because these are kind of put together to group devices together. We can select the junction box, select these light fixtures. They'll all connect to that junction box, and now we circuit those light fixtures, because the light fixtures are actually what have the load, and are going to kind of our piece that we circuit. And then when we draw the home run, it's going to draw it from, well, we selected the device, so it's going to draw from there. But if we select the junction box, it would draw from the junction box. And now if we draw the home run for this, it's going to connect the loops to the junction box and then the junction box to the light fixtures. So that's the standard Design Master junction box. It doesn't have a load. You don't circuit it. You circuit the things connected to it. There are 2 other ways you can do junction boxes. You can also do a junction box as a receptacle. So when we do the insert receptacle command, we'll go ahead and make a junction box receptacle. And this is a receptacle that is representing some sort of load you have in your project. It's not a receptacle, it's something else. A lot of times a junction box is kind of an appropriate symbol to be using. But in terms of Design Master, we're seeing it as a receptacle. So it's something that has a load. You can specify your load type. maybe this is a little motor or something, and we can give it a motor load. So it's something you don't want to do it as a piece of equipment. You want to do it as a receptacle for whatever reason. So we can specify all that information there, and we'll call this JBox motor. And now we can select that and insert that on the drawing. So there is a JBox, and it's set that you can rotate it. And now you can circuit this because this isn't a junction box. This is actually a receptacle. And so since it's a receptacle, you can circuit it like a standard receptacle. It just happens to look like a JBox. And then finally, you can also do a junction box as a piece of equipment. So for the disconnect type, you can set it to JBox. Again, you specify your load type. This, again, would be something like a motor or something. I did not like that block. Anyway, you would insert it on the drawing, and it would look like a standard piece of equipment with the junction box symbol. So those are the 3 ways you can do junction boxes, depending on what you want to do. Typically, what happens is people trying to use this junction box, and it actually can't take a load, but they really wanted to put a load on it, and the correct answer is to use a receptacle or a piece of equipment. It turns out this junction box functionality, while interesting, is not frequently used. Generally, when people do a junction box, they're really looking at equipment connections and receptacles. Another question, how can I print out the layer list that Design Master assigns to objects? If you go into our customization into layers, we have the export command, which is probably the best way to do that. So within our layers, we have the layer systems, the general, which is kind of just all our general schedule type layers, and then new and existing, and you can create more different types. And these are all the layers that are used for the stuff on the floor plans. And over here, we've got all the things that we can assign a layer to, and then the layer that's being used. It's a pretty long list. And it's a fair amount of work to actually make any changes in here. If you have to change 1 or 2 things, then you can use our interface. If you have to change a lot, or you want to print it or review it, you can export them to Excel. So you run the export layers to Excel. It'll export the layer system you have selected. So just be aware that that's what's going to export. So we'll select the new, export layers to Excel. It's going to export it as a CSV file to your current folder. And then it'll attempt to open it using your standard, whatever Windows thinks it should open it with. It should default to Excel. If you have it on your system, it might open it up in Notepad. So this is just a text file. And now you can go in here, expand your columns and make changes. So you've got your layer keys. You don't want to change this column. And then you've got the layer name used. So you could print this out if you want to, or if you want to make changes, you actually can make changes in here, assign layers, use search and replace, all the nice features that Excel has. Once you're happy with how it's set up, run the import layers from Excel command, select that file, and it'll pull all that layer definition back in. In terms of reusing layers, you really want to get it into our system and then into your standards, and then just have your standards define your project layers. You don't really want to, on each project, be importing layers from Excel. It works. It's not really the best workflow. So we would recommend don't keep like a bunch of Excel files that you import from to get your layers right. Get them right in Excel, get them into our system, and then if you need to, copy layers from your project to your standards, and then make sure your standards have good layers in them so that future projects just have the right layers set properly. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.